equals 6. These are the answers that it cannot be. This is your domain restriction. Did you talk about that in class?
Yes.
Okay. And you don't wait until the end, because if you wait until the end, you'll forget. So you do it from the beginning. All right. All right. So now in terms of how you solve this thing, it's related to the stuff we were doing last time, which is you have to make a common denominator. So the first thing you really want to do is factor anything that you see that can be factored. So this middle one is really 4 times x minus 6. And so you look at the three denominators. I'm gonna leave some space here. And you figure out, well, what are they missing compared to the other one? So like, do you see that this one on the left is missing an x minus 6?
Yeah.
So you multiply the top and bottom by x minus 6. I'm sorry, there's supposed to be a minus sign in here. So I actually like to put that minus up in the numerator, so don't forget about it. Is the middle one missing anything?
No.
No. But what about the one on the right? Is it missing anything?
It's missing the 4.
4. So you multiply the top and bottom by 4. Okay. Now from here, you actually only need to look at the top. And I hope your instructor said that, because you don't need to rewrite everything on the bottom, because the bottoms are now the same. You can focus exclusively on the top, and that's another reason why I moved that negative sign up there. So this becomes, and I would like to actually distribute in here because there's just so much writing. 3x minus 18 minus 2x equals 32.
Okay.
And from here, you're supposed to know how to solve this. You're supposed to say, oh, I've done these, for the last few years. I know what to do. So the 3x and the minus 2x become x minus 18 equals 32. Add 18 to both sides, and x equals 50. And what you do with this answer is you compare it to the ones that you said it could not be. And you're okay. Like if it was 6, you'd say, oh, that's bad. I don't know what to do, but it's not. So this is your answer.
Oh.
So this is it. You're done. Now you could check it. You could check this answer, but it's a lot of work. So you really don't want to do that. You want to rely on the fact that you've done it correctly up until this point. Any questions on this one before we do another?
No.
Okay. All right, so we're gonna do the same set of steps, same set, recipe. Thanksgiving's coming up. Are you gonna cook anything for Thanksgiving or bake or be part of the festivities?
Yeah. I usually help my mom with the turkey.
Usually help mom. Cool. Well, it used to be we had these things called recipe books that nobody has anymore. Maybe your mom still does. And you'd pull it out and you'd read it and you'd have, steps. I mean, that's essentially what we're doing here. So step one is you look at the bottoms and you set them equal to 0. Now you don't set the 12 equal to 0 because there's no x. So for both of these, you find that x is 0, but this is what it can't be. So x cannot be 0. Your answer cannot be x equals 0. So if you get that, it's bad. All right. So now you look at 6x, 12, and 4x, and you figure out what is the least common multiple between the number and the variable. So you can look at them separately, like 6, 12, and 4. What is the least common multiple of those?
The 4.
If you're talking, I did not hear anything.
Oh, The 4.
Okay, so 4 is the smallest, but here's what we're really doing. Let me show you this. You haven't done
Oh,
this in a while.
it
Is
was-
you keep going until you find a common one, and you're like, oh, it's 12.
Yeah.
Okay, 12. So the common denominator here of this thing is 12, but then you got to look at the x. So you choose the x with the highest exponent here. So it's going to be 12x. Okay, so keep that in mind, 12x. So I'm going to rewrite this here. 6x and a 3, and then a 12, and then a 9. And I'm going to put that negative up here in the top. That's generally a good thing to do. And then 11 over 4x. So what you have to do now is look at each of the denominators, each of the bottoms, like 6x, and how do you get it to 12x?
You multiply by 2.
By 2, top and bottom by 2. Then you look at the next one.
You multiply by x.
By x. And then you look at the last one, what do you multiply by?
3.
3, yeah. So now we have a common denominator on the bottom. So again, my opinion is you just focus on the top. You do not need to focus on the bottom anymore. Check with your instructor. Hopefully they're okay with that. They should be. And then I'd like you to try solving this from here. Solve for x. Tell me what you come up with. Actually, yes, you can do this one. It works out nicely.
Oh, x equals -3.
X is -3. Is that what you said?
Yeah.
Okay, now you make sure that that is not the same as one of the ones you came up with.
It's not.
So this is okay. So this is our answer. We're totally done here. Nothing more to do. All right, so let's look at number 6, because it's a lot like the one we just did, and see if you can tell me the common denominator after you start looking at it. Or actually, no, we shouldn't do that first. The first thing we should do is figure out what x cannot be. X cannot be 0 because 5x cannot be 0 and 2x cannot be 0. So you always have to do your domain restriction first.
Oh, I have a question. So, is it just 0 for every single one?
No, it's wherever the bottom equals 0. So let's go back to the first one. Say you said x minus 6 equal to 0.
Oh, okay.
You set whatever the bottom is equal to 0.
Okay. I get it now.
Okay, and you got to do it first, because if you don't, you'll mess it up. Now, between 10, 5x, and 2x, can you tell me the common denominator?
10.
10, anything else?
10
Yes. There's so much hesitation in your voice. Yes, 10x. 10x. X. Yes, it's gotta have an x, okay? All right, so I'm just gonna rewrite it down here. And you notice I've been leaving some space as I write it. That's because I know I'm gonna multiply the top and bottom by something. Okay. All right, so how do you get to 10x from 10? What's missing in this first term?
x.
X. You multiply top and bottom by x. And then for the second one here, what are you missing?
The multiplying by 2.
2. The last one is a 5. Okay, so you look at the numerator. And there is a plus here. So now you just need to look at the numerator. Okay, so it's x plus 8x equals minus 45.
So it'd be x equals -5.
X equals -5. Very good. Now, is that a restricted value? No, not even close. So this is it.
Okay.
Let's do a few more and then we'll go to graphing. Some problems here. Let's do this. Let's look at like 5. 5's a little more difficult. Okay, so this one, what is different about this one compared to the previous ones?
The first one can be factored.
Yes, that's true. And actually, I take that. You probably should factor first and then set them equal to 0. Now, you should always think that the other binomials that are given are probably the ones that work out into this one.
Yeah.
And it is the case. It's often the case that that does work. It would take a very difficult instructor to not do that. Okay. So you set those equal to 0. Now you don't just set them all equal to 0 because they're duplicates. But you have to set them equal to 0. And this is what x cannot be. X cannot be. So x cannot be -2. X cannot be -3.
Got it.
Right now, I'm going to rewrite it here in the factored form. Actually, I didn't even leave any room here. Okay. So you have to decide what is the common denominator. Like what is missing from the 2 in the middle, this x plus 3.
X plus 2.
X plus 2, yeah. Top and bottom times x plus 2. And then the one over the right here is x plus 3, x plus 3. And again, once you get the top, or once you get the common denominator, you don't need to rewrite the bottom. Because you've already handled it with this domain restriction. Okay, so it becomes 12 plus 7 times x plus 2 equals 2 times x plus 3. You can distribute in here 12 plus 7x plus 14 equals 2x plus 6. So it looks like x equals -4 when you're all done. And that's okay. That one works out just fine.
Yeah.
All right, let's do number 8, and then we'll move on to the other stuff you sent, the graphing. Although kind of seems like review, but we'll look at that here. All right, so when I look at this one, it's just like the last one in the sense that the squared factors into the other two. You should check it, but it generally will.
Right.
right? The assumptions make a blank out of blank, right? You got to be careful. You got to do a foil here just to check. So you still want to set them equal to 0, not equal to 0. And eventually you'll get one where there is an exception. Like we're doing this because you'll that one problem on the test will have one of these that's the answer. So x cannot be 6 and x cannot be -2. And maybe this will be the one. And I like to leave it in the factored form here. So again, just like in the previous problem, you're going to add what's missing. So this x plus 2, x plus 2, x minus 6, x minus 6. You see how this is a recipe now?
Yeah.
What kind of pie are you going to make this year? Or do you buy pies?
We make probably apple and cherry.
That sounds amazing. A lot better than Halloween candy, actually.
Yeah.
All right, so we distribute in 2x plus 4 plus 7x minus 42 equals 4x plus 2. Combine like terms. Move things around. And you get x equals 8. No problems here. Any questions on this before we move on? Something else?
No, it's pretty easy.
Yeah, I like the way you said that, because that is truly the case. Okay, so we're graphing some sort of a function here. Let's go to the challenge. We don't want a challenge.
No.
Okay. All right, let me look up some problems here because you've already done these. Is that right?
Yeah.
Okay, let me find some similar ones to do. Okay, so this one is now are you just graphing, or I'm sorry, are you just finding the slant asymptotes, or are you graphing this?
Both.
Both. Okay, fantastic. So there's a lot of steps when you're graphing these. And are you allowed to use a calculator?
No.
No calculator?
No.
Okay. First thing you want to do is factor, top and bottom. Is the factored form tells you some things and the non-factored form tells you others. So this is x minus 7, x plus 1 in the numerator. Let me know if, no, I'm sorry. This does not factor. I apologize. That's completely wrong. That is completely wrong. Why did they give us that? Yeah, it's all right. That's all right. Okay. So if it factors, you factor. Now, the first thing you look for are what are called holes. Actually, domain. We should do domain first. Does your instructor ask for domain?
No.
Okay. So holes, do you remember what holes, how you figure out if there's a hole from the factored form?
No.
Okay, so it's if the factors cancel. Numerator, denominator. So there are no holes, okay? Second thing you look for are vertical asymptotes. Do you remember where vertical asymptotes occur?
Yeah, so when you set the numerator equal to 0.
You set the bottom equal to 0. So x
Well,
equals,
this,
yeah, -5.
yeah.
So when you have something like this, that's when you start graphing. Actually, I'll do it over here to the right. So you go to -5 and you draw vertical asymptote. Yay. Actually, I do want to change this because we can't do everything on here, but actually, let me just look real quick at this. Sorry, I shouldn't have just randomly picked one. It's really doesn't work out nicely. I'm just going to graph the numerator and see if it actually intersects. It does. Okay, let me change this to -7. Then it works out somewhat reasonably for us. Okay. All right, so now just that factored form is x -7, x + 1. Doesn't change anything else we've done. So after vertical asymptotes, you look for horizontal asymptotes. And that's where the slant asymptotes can come in. So the reason there's a slant asymptote, Paige, is because the degree of the numerator is greater than the degree of the denominator. Was that explained in class?
Yeah.
All right, so since the x squared is bigger than the x, you're going to have to divide. Now you have two options. You can either divide using polynomial division or synthetic division in this problem. Which way was your instructor having you do it in class?
Polynomial.
Polynomial, yes, polynomial. Okay, so x + 5 goes outside the house. X squared -6x -7 goes inside the house. Do you remember what to do from here?
You put how many times x goes into x squared, which is 1.
Yeah, if you could just speak up just a tiny bit, that would help me. Or get a little closer. There it is. I can hear you now. I kind of heard this x times x to get x squared.
Yeah.
And then you take the x and you also multiply it by the 5, and that's 5x.
Yeah.
And then from here, I like to call it change the signs. So it's positive becomes negative, it's positive here becomes negative. And the reason is because I prefer to add, and I think you should adopt that as well. Adding is much better than subtracting. So you have x squared minus x squared, that goes away. Minus 11x minus 7, you bring that down. And then you restart your thinking. You're like, okay, how do I get to minus 11x from x?
You multiply it by 11.
Minus 11.
Yeah.
Because you want to get exactly minus 11x. So you just multiply by each of these. Okay. You actually don't have to go any further than this, but we'll carry it out here. And then again, you change the signs, change the signs, change the signs, change the signs. Plus plus, because they were negative, and then you add, always add. 48. Like I said, like this number is not important. What is important is this thing up here, up above. This is your slant asymptote. This right here is your slant asymptote. Okay, so it's literally the equation y equals 11, x minus 11. Now I've got a problem here because I've made this, scaled this improperly. So let's go by 1 like that. Okay, and so minus 11 crosses way down here. 2, 4, 6, 8, 10. So crosses right there. And same thing up here, crosses at 2, 4, 6, 8, 10, right there. So there's your slant asymptote.
Yeah.
Okay, what's important is that like your graph's going to have, it's going to fill in, there's still 4 sections. You're going to fill in, the other 4 or 2 of the 4. Is that okay?
Yeah.
Great. So now after you find the slant asymptote, you go and find the x-intercepts and the y-intercepts. So the x-intercepts are when the numerator equals 0. So you go back to that x squared minus 6x minus 7 and set it equal to 0. And you want to use the factored form. So do you see how you get the get 2 x-intercepts this time?
Yeah.
Because you set them both equal to 0.
Yeah.
So x is 7, x is -1. So you go back to your graph, and that's where it crosses there at -1, because I'm going by 2. Should maybe make a note of that, by 2. And then +7, 2, 4, 6, 8. So right there. And we actually now have enough to graph this thing. And that's why I asked if you had a calculator, because if you did, you could just sort of like fill it in like that. And then it's always alternating. So the other one is down here. So maybe we should focus on just the slant asymptote for the time being.
Yeah.
And I'll choose a slightly more difficult problem for that. Just something not as nice, say. I don't like this one though. Yeah, let's not do this one. I'll just write it. Okay, so the problem would be like, oops, red's bad. There's actually a teacher on Facebook asking what color pen they should use to grade papers.
Oh.
What is your opinion on that? Do you like red?
Not really.
It's kind of negative, isn't it?
Yeah.
Yeah. All right. So here is, let me make sure this doesn't actually factor. Oh, it does. I gotta be careful. Let's go 4. Okay. All right. So what is the, not A, what is the slant asymptote for this one? So in terms of what you do, you need to do your polynomial division. Do you want to try this one on your own?
Sure.
Give it a try. I'll be right here if you have questions.
So I got 3x plus x.
Okay, it can't be X. So let's go through this here. I mean, 3x is good. So you get 3x squared plus 12x. Is that what you wrote? Because you multiply the 3x by both.
Oh, that is why I messed up. Okay.
So give that, keep going from here, see if you can work it out.
Gonna be plus 13.
Okay, so you think it's plus 13 there? All right, so again, you change the sign, so it becomes minus and minus. Okay,
Got it.
that's really important there, rather than subtracting. So it becomes minus 11x. Bring that minus 2 down. So do you see how from here you can you've got a different number, becomes minus 11
Yeah.
because you want to get to that minus 11x.
Yeah.
So that becomes
Good.
minus 11x minus 44, but you actually don't care. Like you actually are like, all right, because you only need this thing at the top, but you do change the signs. And then you do get positive 42, but that's not even important. What's important is the thing at the top here. So that's your horizontal asymptote. So let's try another one. You've got to be able to get this division down. I know it's not interesting, it's not exciting, but it's necessary for your class. So x plus 3 goes out here. X squared minus 6x goes here. Could you give this one a try, please?
I got x. I think x plus or minus 12. I think minus.
Okay, so let's put an x here. You multiply each of them by x times x, you get x squared. The x up here above times the 3, so that's plus 3x. But then you change the signs. Change the signs. Okay, so it goes negative, negative, because the 3x is positive. And then you add. So you're adding up here. So that becomes 0. The first one should always be 0. Minus 9x minus 1. Let's try again. It's not 12. What goes up? What goes up here to get to minus 9x?
Negative 9.
Negative 9. Yeah. So now you take that negative 9, you multiply it by x and 3, minus 9x minus 27. Change the sign of both. And you end up getting 26 as your remainder. But you don't even care about that. Y equals x minus 9. That's your slant asymptote. So have you try one more. I know you can get this. Completely correct. Give this one a try, please.
Is it x minus 3?
Say that again.
Is it x minus 3?
Let's try it. X minus 5 outside. X squared plus 2x minus 12 inside. So that gives you x squared minus 5x. Looking good so far. So change the signs and you get 7x. Uh-oh. So I think you're not doing that part where you change the signs. You got to change them both.
Because it's -5.
Right, so it becomes +5 when you change the signs.
No.
I mean, you could think of it as subtracting, but you're not gonna, this is a better approach long term to do it this way. So it should be 7, x plus 7. Because that gives you 7x minus 35. And then again, you change the signs. And that you change them both. So it becomes negative and positive in this case. Remainder of 23. Let's try one more. Try another one here. Let's go 4x squared minus 3x plus 2 over x minus 1.
Would it be 4x plus 1?
Okay. Let's say you had to do 10 laps if this answer was wrong, swimming. Would that be enough to get you to check it again? Or how's that for a punishment on right and wrong?
Oh, that's pretty good.
Okay. All right, well, the 4x is definitely correct. So I like that. So that's 4x squared minus 4x. Okay, now we're going to change the signs. So it becomes 1x, bring that down plus 2. And then you're trying to get x, so you put a 1 there. And I think that's what you said. Yeah, that's perfect. Very good. All right, so let me go back and look at your notes that you sent over, see if there's some other things we can talk about here. Yeah, let's go through some of these. Just do a kind of a rapid fire thing on some of this other stuff. So let me give you another problem here. I didn't close that out. All right, so let's look at this one more time. I'm going to ask you some different questions now for this. All right, so what is the equation of the vertical asymptote?
Is it 2x plus 6 equals 0?
Yes. Did you solve that for x?
Oh yeah, it would be x equals -3.
Very good. Okay. Now, what is the y-intercept? We didn't do this earlier, but what is the y-intercept? How do you figure that out?
Don't you set the top equal to 0?
So you actually set x equal to 0.
Oh, I'm thinking of something else.
Yeah, that you're thinking of the x-intercept,
Yeah.
which this one is not really set up for, but we'll
So it would also be -3.
so when you put 0 in for x, right, it's 3 times 0 squared plus 0 minus 2 over 2 times 0 plus 6. So everything cancels except the last two numbers. I don't think that's 3.
Not -3.
Negative,
Negative
negative 1/3 maybe. Good.
Yeah.
Okay, so let's look at another one here. Let's say it's x squared minus 6x plus 8 over x plus 3. I'll ask you some of the same questions. What is the vertical asymptote? What is the equation of the vertical asymptote?
X equals -3.
X equals -3. Very good. Now let's try this again. What is the y-intercept?
8/3. Y equals 8/3.
Say that again.
8/3 0.
Yeah, 0, 8/3. 0, 8/3. Or y equals 8/3.
Yeah.
All right, now, last one, this is new. What is the x-intercept? So this is where you have to set the numerator equal to 0, and this time you have to factor. Can you factor that for me?
Yeah, it would be x minus 4 and x minus 2.
Okay, so that's still, that's correct, but it's not the answer. What's left to do here? You have to set each factor.
Oh yeah, x minus 4 equals 0. X minus 2.
Yeah, so x is 4, x is 2. Any questions on that?
No?
Is there anything else you would like us to cover tonight?
Not that I can think of.
Okay. Well, do you feel like you understand how to solve rational equations, which is what we started out with?
Yes.
And then do you feel like, actually, we did not do we kind of didn't do the first page, but it really leads into the second page for
Okay.
us. If there's an issue, we can cover it another time. And then slant asymptotes, right? So slant asymptotes, the degree of the numerator has to be bigger than the degree of the denominator. And then you're always using polynomial division, right? Polynomial division to do that. And then you just care about what's up here. What's up here is your slant asymptote.
Right.
All right, well, that's probably it for us for tonight. Thanks again for letting me help you, and look forward to helping you again next time, whenever that is. And hope you have a great rest of your night.
You too.
Okay, bye now.
Bye.